My name is welcome to this web demo. We are thrilled to have you here today. And my name is Marcio. I will be the host for this session. The webinar will be recorded, and we will dedicate some time on at the end of the session to do a Q&A round. So today we have one special guest. It's Will Pitarello. I'll let Will introduce himself.
Hey, Marcio. Good afternoon. Good afternoon, everyone. Good morning if you're connecting from the West Coast. Thanks for being here. Like Marcio said, my name is Will Pitarello. I'm an application specialist here with Faro Creaform. And today we're going to have some fun with you, scanning some parts, go over this workflow with you. Thanks again for being here.
Thank you, Will.
Yep.
So our agenda today we will cover the following topics. So first thing will be we will start with a product presentation. We will continue with web demonstration, and then after that we will show the post-processing workflow in Peel.CAD Pro. At the end, we will finish the web demo with Q&A session. So let us know, write down any questions you may have during the presentation. We will be happy to address and provide the answers. So, Will, if you wanted to, start.
Yep. So guys, really, my portion, I guess you could say it's the easiest portion, right? I'm gonna kind of give you a view here on the Peel 3D scanner, pretty much the idea of scanning, what it is, and how it works. Really, right? My end is really little easy because as you look at the scanner, give or take, scanners will work on the premises of cameras that are able to see light, right? As it reflects from the part, you're able to digitize or capture the geometry of the parts and obviously inspect or measure or extract dimensions or create a CAD model, which is a whole lot of you are doing, right? The reverse engineering part of things. So really, this is the Peel 3D scanner. So we got the dual cameras here. One thing that the Peel, and if you guys are used to scanning or have seen this before, one thing that I like a lot about the Peel 3D is that I can utilize the targets, and if you've been around scanner or if you've researched a little bit of homework, you can use the targets, but the Peel 3D also gives me the capability to use the geometry of the part. So as you look at your parts, right, mechanical parts, all these different geometries, and I've got a bunch of parts here on my granite, automotive parts mostly. We got a turbo housing, an engine, basically an engine head, and I've got a crankshaft type of transmission housing right here. So typical parts that are going to allow us to scan. So the good thing about the Peel 3D is that I can use the geometry of the part. I don't necessarily need to use the targets, or I can use a combination of both. The other thing is the infrared light with this ring in the middle here. Well, this allows me to scan in colors. So if you want to use colors, and maybe if colors are important to you, you can use colors with this device. If you don't care about it, then it's fine. You don't have to use colors. Now, as I go into a scanning here, I'm gonna share my screen with you, and we're gonna go over kind of like a typical workflow. So what you're seeing right now is basically our software, right? The Peel.OS Pro software. And in this capture mode, I'm able to choose the resolution that I'm going to scan, resolution being the size of the triangles, or I could choose to let the smart resolution do its job, which is, well, the software will analyze the structure of the part. It will apply the zero 0.8 or the 1 millimeter, whatever resolution you choose overall on the part, but it will know if there is a whole lot of details. Well, I'm going to apply a finer resolution. So you do have such a thing as a smart resolution. The same thing for the shutter, for the exposure. So if you're dealing with dark parts, if you're dealing with light parts, you can override the automatic shutter. But the automatic shutter is really nice because it will discern the type of parts that you're scanning. So as I press the button to scan, on the LCD screen of the PU3D, I've got my play button, I've got my zoom in and out. I can override that shutter. But hey, the act of scanning, right, guys? And first, I always like to give kind of like a show of power, display of power, how quick first I can scan the different materials that I have here. So I've got rubber parts, I've got a gear, I've got the ferro arm. And as you can see, as I kind of go up with the ferro arm, I do have targets on the granite, but I have no targets whatsoever with the arm. So it's using the geometry of the arm in order to scan that. As I move on to this side, I've got this plastic part. It's usually our demo part. I've got my engine head, my block, and aluminum casting basic material. I've got a part down here that's got targets in it, and I got the same part right here without targets. The feedback from the scanner is this, right? This beige data that you see, that is optimal data, which means that I don't have to keep looking at it. I don't have to keep spraying on those parts. I can just move on. But then you can see a fraction of a yellowish type of data. And that is the software kind of asking for me, hey, maybe you improve the angle on these areas, or maybe you kind of spray a little bit more, right? And as you can see, I'm moving really fast on this portion. Up in here, I've got my turbo compressor housing. It sits on a rotary table. So observe what happens as I kind of move this around or put the rotary table around. I'm moving it. It's a smart way, right, to scan a part without having to go around the part. Because the table is moving, you've got your targets or geometry. Well, it will see pretty much and it will discern about that. So that back to that yellow data. And you can see in the nooks and crannies, it's telling me to go and focus a little more. All right. So that was a quick scan, large area. You can see my ferro arm. You can see my casting, kind of this round, nice little part. You can see the rubber part. Now, let me show you this, right? We have this transmission housing. It's actually sitting on a rotary table as well. Again, like I said, it makes it easy for me to go ahead and scan, especially on a part like this, right? All these ribs for reinforcement. I can kind of just go around the part. The other thing that I'm going to talk about here is what's going on in the screen right now and what the feedback of the screen is relative to these laser lines, or sorry, not laser lines, but the structured light that is hitting the part. You can see if you're kind of in the green space or the green area, well, that means that I have a good distance between the part itself and my scanner. But as I try to go in or to move in a little bit closer to the part, you will see that everything kind of becomes red. Well, it's still collecting data, but it's telling me that I'm now too close to the part. So I back up a little bit. Same thing happens if I go the other way, right? So if I go too far from the part, everything is kind of blue. All these lines are blue, and it tells me to go in a little more. One thing that I'm feeling here, guys, and you're not, because you're not holding the device, of course, is that there is a cue that tells me if I'm not looking at the computer screen, there is a cue, which is the device kind of shakes a little bit, or there's this pulsating thing that I feel in my hands. So it vibrates literally, so that I know that I'm either too close or too far from the part that I'm scanning. Other than that, guys, look at this, right? I'm just going around, I'm covering the part, and that little analogy, the spray painting, it applies, right? The other thing that I like to say here, depending on the end result, either if you're looking to inspect a part or if you're looking basically to do a reverse engineering, well, a little bit of more care as you scan the part. Well, maybe it goes a long way, right? You see that there are holes on the part. Of course, I have to take my sweet time, especially in a part like this, full of details, and kind of cover the part. Can you fix these holes in the software? The answer is absolutely yes. And sometimes, guys, there are just nooks and crannies that the scanner cannot access it. So you would have to resort to software in order to fix that up. But here's what I say, right? A little bit of more time, taking time to do a proper scan will go a long way as you start going into this post processing. Uh, what else in here? I think I pretty much said anything that I needed to, guys. I'm gonna send it now to Marcio so that he can show you a workflow, right, with the data. And he's got his part. He's already scanned it, and now let's go into the workflow in the software. With that, Marcio. You are on mute, Marcio. Please unmute yourself.
Sorry.
Yeah.
Thank you, Will. Anyone has any questions so far? So on the scanning part,
Yeah.
let us know.
So remember to write down your questions, right, guys, so we can address it at the end.
I have one here. If you wants to, if you, the question is, can you go back and fill the gaps with the scanner?
100%, right? Great questions. Thank you for saying that. So let me once again, right, share this with you. So you saw me basically. Let me just share the right window here, guys. Okay, so share the software. So you saw I stopped scanning. I stopped talking. I was gonna send it back to Marcio, but I still have my scan in there. So, and this is a great question because not all the scanners out there can do this, right? I stopped. I'm gonna zoom in, and I'm thinking I got good coverage over here, but look at that. There's a bunch of holes on this area of the part. All I gotta do again is to press the scan button, go in, kind of look around where I need to. I'm gonna give it a little bit time for the scanner to kind of get the proper alignment because it sees all that number, that 25 number or 52. I think it's upside down, right? But now I can go back and cover the areas that were missing before. Great question though, right? Again, it's using the geometry of the part in order to understand the alignment to the part where I left off. I can actually piggyback or pick back where I left off. Great question though.
We have another question, Will.
Yep.
It's if you need to scan inside of the part, can you flip and how do you proceed?
That is that is a great question, right, guys? So maybe I'll show that, right, Marcio, on this different. Do I have a little bit of time to do it, or do you want me
Yeah,
to?
go
Yeah.
ahead.
So okay, I'm gonna show you this capability using this part. Now understand this, right, guys? You can use common geometry of the part itself, or you can use a bit of targets. I've got a an overkill in terms of targets here, but I'm just going to show you how it goes. In this particular case, I'm going to use the targets in order to do what we call the registration or the alignment, right? So I'm not going to take too long here. I'm just going to scan really quick so that we can show that the workflow. Like I said, right? There are some areas of the part that you're always going to have a little bit of hard time going in because it's just that game of scanning on line of sight. So check that out, right? it allows me to show you a bit of the cleaning tools on the software. So for example, I could care less about the table, right? So what I'm going to do is I'm just going to hit a couple of points here on the table itself. So 1, 2, and 3 points. And I can say, create something in here, which is kind of like that clipping plane. I can keep on going with that on 3 vertices. I can do it via some other ways. One of the cleaning tools that I like here, just in case if you have some noise, right? And I do, I like this capability here, the connected data, which means that I click on the part itself, it ignores all the other noise, and then I keep only what I like, what I need, and that is the part. Another thing that I'd like to show you here, guys, and I can, right, is the finalization process. I'm just finalizing it. And look at that, right? Look at the result after I finalize. The software understands, in this case, the position of targets or the geometry, and it finalizes it, it eliminates it. It's still here, but I just don't see it. So that is the outside of the part. I kind of hit this invisible area right here. I'm going to add another scan. And what I do is, look, I'm going to flip the part. In this case, when I do it, the same targets that were, in the field of view in this position are still in the field of view in this position. And the software, in this case, it's going to use the targets to stitch together the two sides. But like I said, instead of using the targets on the side, I could use the geometries of the side, because this part is very unique in itself, that I can guarantee that the scanner will use the geometry of the part. And I keep repeating that, guys, because let's say if you scan without targets a flat wall, you're not giving the scanner any geometry so it could stitch the part together. So it would not work. But usually mechanical parts or whatever parts you're trying to scan are unique enough in terms of geometry so that it knows how to stitch it. Again, I'm kind of scanning really quick right here. All that I care about right now are the targets on the side of the part, because again, like I said, the software will use those targets in order to stitch that together. Same thing in here, right? I'm gonna just stop the scanner. I'm gonna click on the table, I clip it, some noise. Once again, I resort to the connected data. It ignores the rest. I say keep only, and it keeps the scan. I finalize it. It ditches the targets for me. I don't need to visualize it. And now I go into the actual alignment. So you can see top and bottom, kind of like one on top of the other. I'm going to do a target best fit, meaning that I use the common targets, and I already did, right? And it shows in red the common targets that are stitching it together, right? So in this particular case, I used 10 targets or 4. You can use a minimum of 4, and it gives you the deviation per target. So zero point 0.7, 74 microns, 75 microns. I like that number. I accept that deviation. And now I have the top and the bottom. All that's left over for me to do is to merge the two scans together, accept it, top and bottom there. Again, I did it by using targets. You can do it by using targets or common geometries on the part. Again, it finalizes and it gives me the end result. Now, if I look around, that little gray, the lighter gray is the top, and then the darker gray is the back of the part. Again, and I'm still in the capturing software. I can now send it to a scan to CAD or to an inspection software.
And the other thing to mention, Will, it's when you do that merge, the third scan, the third file, it's created on the tree view. So you're not deleting any of the raw data. So he keeps the 2 sessions, and then it's creating a third file.
100%.
Thank you, Will.
Anything else, Marcio?
No, no other questions for now. So guys, anyone has any other questions? No, don't have anything. So I will go forward with the Peel.CAD. So when we finish that scan, we can send the file to directly to Peel.CAD. It's just one button, as you could see it. So I will share my screen now, and let me know if you can see it.
Yep, we can see it, Marcio.
Good. So here I have this pipe with two flanges. It was scanned in two different files. As you can see it, we can do this merge of the scans in the scan module, but we can do as well in the post-processing. So if we have two files, we are able to align them in the post-processing and then merge them as well here on the Peel.CAD Pro. So on the Peel.CAD Pro, the edit tools, we have on the top, we have the edit tools, entities to create planes, cylinders, reference geometries, modification to modify the mesh, fill holes, dismate, smooth the mesh, and we have the modeling tools to do our sketches, revolve extrusions, auto surfaces, and compare as well the scan data with the CAD model. So here we have selection tools. It's we can grab and just drag whatever we want the tools. So you can pin to keep it on the top of the tools as well. So the first thing here, if we approach this, how we're gonna create a solid model for this part. First thing is to align the two scans. So they are not in the same alignment. So we're gonna do this. The first thing will be to realign the parts together. So here under alignments, we have this, there is this tool available, best fit. So I will use the best fit. We will use it the targets alignment. So he based it on the common targets. I will do my alignment using common surfaces. So here selecting the fixed and the mobile. And then there is automatic manual with 3 points or some options to do the alignment. So I will try to do automatically first, and then we can hit the best fit. So if software finds the common surfaces, then we will have the two scans aligning. So that's a good indication that the alignment it's good. It's when you have this mix between the two colors. So once this is done, the two scans are aligned. So they are aligned, but they are still two different files, right? So the next step will be the merge the two scans together. And then here under merge, edit tools, merge. Even if we have more than two scans, we could select it so they will be all available here, and we can merge multiple scans at the same time. So once select both of them and apply, so then we're gonna have a third scan under the trivial, and we're gonna work with this one. Accept. So now you can see it here, the third scan. So let's say this is the merged one, and I will hide the first two scans. So let's work only with this. So as you can see now, we have the top and bottom on the same file. So there is many ways to approach this, how we do this reverse of this solid. There's no wrong and right then. It's just if you can get this done, doesn't matter how you do it, but what I will do, I will start to creating my references. So entities reference to be able to first create this flange and then create the second flange at the top. So under entities here, I will create my planes. So those will be my reference planes. And to create the planes is just once you select the plane, put this here, it's just the selection tool. It's selecting meshes. And then when you select the plane, the software will understand that you want to select a plane, and the software will automatically switch the selection to manual similar normal. Sorry. So all the triangles pointing to the same direction will be selected, and then it's just one click, and the software will best fit a plane. So I can drag and drop, extend the planes, but yeah, it's just click OK. You have that color scale that where you can see the error distribution, and I will create my 4 planes here, top and bottom from the 2 flanges. So we have that. We can this file, it's not aligned. So one of the steps is to when I was doing the alignment, I was aligning the 2 skins together, but then there is a second alignment. It's to replace the coordinate system. So right now the coordinate system it's here on this space, and normally we want this with the part. So we can use those planes. I will create some other entities, cylinders, and then we will have everything to create our coordinate system. So again, only one point we can. The software will best fit the cylinder. I have only a small portion of the cylinder, so I will do another click and expand the selection. Software, we are able to extend as well the cylinders. So if you want to use this, create solid surface, it's possible to do in this step. So I do one cylinder, and then I will create one circle as well. So for the circles, we have to have one we have to define a constraint plane, and this is going to be my plane 1. And then I will select boundaries, and we'll do one circle. So software is best fitting the circle using the boundaries of the scan. So then when I have my 3 defined entities, I will realign the part. So to align, we have this manual alignment, and it's where we're going to define the planes, the axis, and the constraints to align that part. So in this case, I will use here my entity plane 1, and this is going to block my X and Y, so blocking the Z axis. I will use the circle to create my origin XY, and then I will use that cylinder to block the remaining axis. So we have, this is fully constrained and all the degrees of freedom are locked. So now my XYZ it's pointing, my Z axis is pointing down. If I want to flip this to point up, we can use this button here to flip the normal. And now everything is going up. So this is one of the first steps. It's to align the part, and now we can use our views here to see the part aligned. So in this process, let's start to create our flanges. So we create bottom and top and bottom flange. And to do this, I will use the create sketch tool. So creating this sketch, it's we will define our plane. It's like any CAD software. So first thing is to define the plane, and then we can position the plane where we will be able to extract the surfaces. So let me hide the cylinder. So as you can see here, we have all, using this tool, we have all the profile of the flange. It's a really useful tool and really easy to create and extract the profile. So here we have our profile, and then we can start sketch or part. So in these sketching tools, it's similar to any CAD software. So you have the lines, circles, arcs, and so on. And then one of the really nice tools is the automatic sketch tool. So basically, we just need to select what are the lines we want to recreate or to draw, and then we can apply. So applying, it's the software will add constraints, and then you are free as well to change them here. So let's, here on maximum deviation, we can see how much deviates from our adjust deviation. So let's put this 20, and let's decrease this segmentation level here to 20 as well. So then it's gonna, the fit with the surface will be a little better, and then I will adjust as well our tangent threshold. Oops, it's not bad. So let's keep this at 5. So we still have to do some adjustments later, and we can do it manually. So we will accept that, and then I will just do a quick select, just select really quick here this line, and this line as well here, and we can, I will recreate with an arc. So reposition this line, and let's use the arc to replace that. So here we have the measurement of this segment, and you can have, they can be the same as often. So 229. So I can adjust this to 29 to be. to have the same same measurement as this one. So for my circles here, I will delete them and recreate them. Oops. Delete that as well. And I will recreate those circles. Oops, this one as well. Let's put this all with the same dimension. And let's recreate our circles. One, two, and three. So now we have our 3 circles, and we can accept the sketch. So after accepting the first sketch, we will be able to extrude using the extrusion tool. So on the extrusion, we just need to select the modeling, the sketch. Oops, that's my sketch. The sketch was not created. Sorry for that. I think I forgot to accept my sketch. Too fast. Let's do it again. And at this point, I think we'll just redo the circles. So you all have seen how to do it. So let's redo the circles. Redo some of those planes.
All right, Marcio, we do have a question from Dan. I'm currently using Peel.CAD along with SolidWorks. Could you please explain the key advantages of upgrading to the Pro version and in which scenario I would provide the most value? Yeah, so
The Pro version, you have, with the Pro version, everything you created here on the modeling, if you can transfer to SolidWorks. So most of the tools like those cross sections that you have been creating and sending over to SolidWorks, you now have the possibility to do your sketches directly here on the Peel.CAD. So it's just saving that back and forth between SolidWorks and CAD softwares and the Peel.
Do you mind
software.
if I share the screen a little bit, Marcio?
Yeah, go ahead.
Yeah. So then the idea is, right, you are drawing in the Peel.CAD Pro software, like you see on the screen, right? So you are constructing your tree, you're constructing your solid, you are constructing everything inside Pro. You're not doing in SolidWorks. The biggest advantage here is that first, this tree that you can see on the view, right, and all the extrusions and all the lofts and this modeling, well, this is going to be saved for you. You're going to be able to have a color map and understand this, right? This is a color map of what the mesh you had and the parametric you created, and it tells you how true by means of the colors, just like in an inspection case, right? By means of these colors, you know how good, how close you are, the error distribution, I think Marcio mentioned, right? So in the green areas, you're good. In the red areas, you're a little bit high. Do you want to keep it? Do you want to keep on editing? And this is something that SolidWorks does not give you. So you can see the revolving and all of that good stuff. The end result at its final, you can see the color map and this nice button that Marcio just mentioned, right? The ability to transfer directly into SolidWorks. Well, here's the button down here, transfer to SolidWorks. It opens up your SolidWorks and it works in Inventor as well, right? So the whole tree is in here. The tree is editable. You can edit, finalize your CAD model in here, and you can even leap back and forth back to Scan to CAD Pro if you want to fix something in Scan to CAD Pro. So basically, that would be the biggest advantage of you modeling inside here instead of modeling directly inside here. Sorry about that, Marshall.
That's good. And yeah, that's true. So you can, after finalizing your reverse engineering, you can import as well the CAD file to Peel.CAD Pro. So you'll be able to do that color map where you can see the deviations between your part and the scan data. Other than that, it's the possibility to import as well any mesh file. So you can use any mesh file in Peel.CAD Pro. So going back here to my part. So now I have this my initial sketch, and then I will pull my extrusion. So here it's pointing down, but we can use here the select pick a vertex, and then we can, it's with one click, it's going to be up to the that surface. So we have our first solid. I will do the same for the top. So same thing, create sketch, selecting one of the planes, so the top plane of the bottom, replacing the plane, and then the software will extract for us that curvature. So again, selecting all, adjusting, I will adjust the segmentation level and apply. Do we have other questions, Will? If you can, let me know.
Yep. Yeah, let me take a look.
Now I go for viewer. Okay. We can create all that in SolidWorks without Pro. Yeah, it's you'll be able to create in SolidWorks. That's it's up to you. It's now the
Yeah.
solid. Yeah.
Yeah, I think the only disadvantage, Marcio, you would not have that color map, right? SolidWorks does not give you that capability to color map between the mesh
between the
versus the,
mesh
yeah, and
versus the solid. Right.
the solid, right? So yeah, William, you would have that. You could do it, right? I mean, make no mistake, right? You still can model, and SolidWorks is a modeling software. But in here, you have that nice capability to visualize in terms of those heat map, right? The basically what your parametric looks like versus the mesh.
Exactly. Grab this. I'm selecting here again or solid, and I will pick the right direction. So we have, with this, we have our two flanges. Right. So it's really, yeah, it's easy with this automatic extraction. So you have all these those profiles created with only one feature. So then for the flanges, it's more a mechanical geometry, and let's do right now this the center of the pipe. So where it's something more organic and more difficult to redraw, to redesign that. So what do we do? It's I will create with the sudden change. I will select the part, so the center of the pipe, and do with this similar curvature. So similar curvature will select all the triangles with the similar curvature, and then I will extend this selection using the growth extension, and do a quick manual selection here. So once I get that, this is not selected, this is not selected, and that's good because we don't want that on our mesh, on our final design. So with this selected, I will create a copy, and then right now I'm working with this copy mesh file. So first thing, I could fill the hole. We could fill the holes only using filling hole, or what I would prefer to do before to fill the hole is to, with the selection tool, select the boundaries, select this boundary, and clean the boundary before selecting the hole, filling the hole. So I will extend the boundary a little bit more, delete the first one, and I will do the same thing for this as well. So this is one way to do it, to clean the boundary, and then I will fill the holes, the two holes. So sometimes it's not, we still have that curvature, and I will show how we can get rid of this to get a smooth surface. So here is better, but I still like to clean a little bit more this. So we will accept the two holes, the two filling holes, and I will do a quick selection here. Maybe too much. Select that a little bit more here. And the tool that I will use is the defeature. So the feature is basically it's removing the data and then filling out the data with the surrounding triangles. Do the same here. and then this mate. Not this mate. Sorry. It's not the this mate, it's the diffuser. So diffuser cleaning everything for us. I will do another tool that I will use. It's to clean this the bottom of this pipe, and to do that I used edit boundary. Before to do that, let me do something else. Before to edit this boundary, I will use the cut mesh to clean that boundary, and use one of my planes here. Plane 1. I would send this plane to the merge copy. So I will send the previous plane to the mesh that we are using right now, and then cut mesh using that plane. So now let's use that plane too. Let's not keep both parts, and let's preview. So it's deleting that surface that we don't want it. So let's flip the normal and preview. So we cut the good one. So once we have this cleaned, let's use the other tool will be extrude the boundary. So extruding the boundary, I will use that to cut later my the cut or solid with this. Just checking if I have here. Okay. So extruding boundary, I will extrude, select that boundary through the plane. So plane 1 will be use it, and let's extrude. It's the extend boundary, sorry. Extrude. Selecting the plane. See why it's not working. Versus. Yeah. It's just, I don't know why it's not letting me select that. Okay. So let's extrude that plane, and I will extrude a little bit more. The only thing I don't want to fill that boundary. So Let's cancel and do it again. So I have my extrusion, and then so now you can see it. We have our solid from this merge file here. I will create an automatic surface. I could do the same thing for the top as well, but let's just save time. Let's do it for only the bottom of it. So under modeling, auto surface, the auto surface will create a NURB surface, and I can use this to cut my solid later on. Why is this? Why the Peel software able to handle the mesh much better in SolidWorks?
I was kind of answering that,
Go,
right,
go
Marcio? I
ahead.
mean,
Go ahead. Yeah.
it is a software, William, designed for scanning, right? For our platform. So obviously the algorithms are tailored to scanning capability with hints of CAD capability. So you can draw in Scan to CAD Pro. We don't have all the tools yet, and it's an ever growing thing, right? We're continue updating on Scan to CAD Pro, but it's not a CAD software per se. On the other hand, SolidWorks is not a scan software. It is a CAD software. So that's why you can see the capture handling much better inside that. Sorry about that. If you have anything to add, Marcio.
Yeah.
Yeah.
And all CAD softwares, they will have a hard time dealing with all the amount of points that a 3D scanner can create. So here we can see it, the number of triangles and the points. So it's almost 500,000. And CAD softwares that you will have, yeah, it's going to be difficult to then too heavy for CAD softwares to deal with the meshes. Great. So we have our automatic surface, and so we're gonna accept that. So in parts like this where geometry, it's an organic geometry, this kind of tool will help you a lot on the reverse engineering process. So now I'm creating two surfaces, and I can show you the fit between the surface and the scan data, so we can see how much it deviates from the scan data, the physical part. Just hit OK, but I should not. So the next step will be we have the automatic surface, and I will use that surface to cut or solid. By the Peel software. So this William was Will. Do you have any other questions, Will?
I think we answered them all, Marcio. William basically was asking, right? Uh, yeah, we got Maria answered the other questions.
Good. So we have that our surface, and if you want, we are able to compare the surface to the reference, like the color map, and see the deviations. So here it's how much. Let's put this. Adjust the deviations, but as you can see, everything it's most of the surface it's between 0.1, 0.01 and 0.0 minus and plus 0.01, so 10 microns. So that's how good is the fit with the NURBS fit with the mesh file. Okay, so then our surface it's created here, automatic surface, and we're gonna use this to cut or flange. Let's bring back our flange, and the target body will be flange, tool body will be our surface, and then the resulting will be this. So, okay, and now what was, let's go back here just to show you what was a closed solid here. Now we have, we cut this out with our surface. So we could do the same thing for the top, and then sending. If you want, we can send to transfer to SolidWorks. So it's opening SolidWorks and transferring all this timeline to SolidWorks, or finalize the file here. So transferring the model to SolidWorks is going to send all these sketches, these extrude, convert bodies, all that timeline to the 3 view. And if you keep adding more to that timeline, you could add more things to the timeline, you can transfer. So it's going to just add to the same project in SolidWorks. So it's just finalizing the transferring. We'll do. If you guys have any other questions, just let us know.
I've got one, Marcio. What's the smallest feature size that can be accurately captured with the PO3 scanner? So the smallest feature size.
I will open something here. 1 second. And it's going to be visual, so we can see the small details on it. So this is the kind of surfaces we will be able to acquire with the scanner. So talking about a pin, the smallest pin will be 1.5 millimeters. For a hole, 3 millimeters. I step 0.1 millimeter, and wall thickness 1 millimeter. So this is visually what the smallest features we can get with the software.
Gotcha. Thank you.
So now my SolidWorks in another. So it's transferring to SolidWorks. We could, here I'm just transferring those surfaces, the solids, the surfaces, but we can export the entities, the planes, cylinders, and the mesh file as well. So everything could be transferred to SolidWorks. Do you have other question, Will?
No questions for now, Marcio.
Okay. Cool. Sorry if it was too long. Let's wait for just to finish this transferring. But then if you don't have any other questions, we can close this session.
And the transfer, Marcio, goes directly, as we call it, live transfer to SolidWorks, to Inventor, to pretty much any CAD package, or what are the options here in terms of CAD?
Yeah, we have
transfer?
direct transfer to Fusion, SolidWorks, Solid Edge, and Inventor. To SolidWorks, we can export the timeline. So it's sending as well all the timeline SolidWorks.
Okay.
So as you can see here, we exported our mesh, surface, and then the solid. I did not cut, but we could trim out this the surface here in Peel.CAD. So Peel.CAD, again, going back to the what William was asking. Here we have in Peel.CAD Pro, you have tools to working with the surface, but surface and this conjunction with the solids as well. If you guys doesn't have any other question, thank you very much for being here. Thank you, Will, for this webinar.
Yeah. Thanks, Marcio, for getting us. Guys, thank you for participating. There's absolutely more to be talked about, right, Marcio, on a workflow, but it requires a little bit more time, right?
Yeah, we have to. But I think it gives the idea of how to do that reverse engineering process. There is other tools on the software. We do not have the time to go through all the tools, but at least I think the most important tools we showed today.
Right.
Thank you very much, guys.
Thanks, Marcio.
Thank you.
Thank you.
Thank you, Will. Bye-bye.